Okay, welcome to lesson 3.8, solving equations and formulas. Today's state, go ahead and put that up in the corner. And our I can statement is that I can solve a multivariable equation or formula for a specific variable. So if you think about a multivariable equation or a formula, both of them have more than one variables. So since our equations are going to have more than one variables today, we need to remember something, that when solving equations with more than one variables or a formula, we're going to simplify fully and expect to have variables in the solution. So even though we're going to go through all of our steps that we know for solving equations, we will still have variables in our solution. Now our steps for today, where we're going to have more than one variable, the very first thing you want to do is identify the variable. So there's going to be several. You have to pick the one that we're being asked for, identify it. Step 2, determine what's happening to that variable. So identify the variable, determine what's happening to the variable. Step 3, do the opposite, which means we're going to have to transpose and or multiply or divide. And lastly, we're going to solve. So these 4 steps are what we're going to do for today's problem. We're going to have to first identify our variable. Second, determine what's happening to our variable. Third, do the opposite. Fourth, solve. So let's look at some examples. Example 1. We're given 3x minus 4y equals 7, and we're asked to solve for y. So step 1, we're going to identify our variable. There he is. There's our y. Now, second step, determine what's happening to the variable. Well, he's right beside of a minus 4, so that means he's being multiplied by a negative 4. And that my symbol also means he's being subtracted from 3x. So if we go back to the rules we know about equations, we know that the first thing we want to do is to look to see what we can get rid of by transposing, what's being added or subtracted. So I'm being subtracted from my 3x. Even though he has a variable, I want y. So I'm just going to pay attention to y right now. So I want to get rid of my 3x first. So if he's positive, I'm going to make him a minus 3x. He disappears. I'm left with my negative 4y on the left side. Equals. Now you have to ask yourself, can I do 7 minus 3x? No, I can't, because he's a number and he has a variable. So they're unlike terms. So that does not simplify. Okay? Now, the next thing we're going to do is say, here's my y. Still ask ourselves, what's happening to y? He's right beside of my 4, so that means he's being multiplied by negative 4. To do the opposite is to divide both sides by negative 4. Okay, so that means our negative 4's cancel. And we're left with y equals. Now, you always want to make sure it can or cannot simplify. So we're going to look and say, can 7 be divided by negative 4 evenly? No. Can negative 3x be divided by 4 evenly? No. So nothing reduces. It all just drops down. 7 minus 3x over negative 4. That's all we have to do. That's our answer. So basically, we're going through our steps of solving equations by transposing first, then dividing. The only difference is nothing simplifies, and we have a variable in our answer. Alright, so example 2. Oh. Okay. Sorry about that, I accidentally went to the wrong page. Our example 2 is D equals RT, and we're asked to solve for R. I'm going to go ahead and tell you that this one is a formula. Whenever we get to a formula, it's always easier if we go ahead and flip it to begin with. That way, we start out with our variable on the side we like it on. So I'm just going to take my whole problem and flip him around to where he says RT equals D. Now my R is where I like him. He's over here on the left side. Now we just have to say what's happening to R. If R and T are side by side, that means they're being multiplied. So the opposite is to divide both sides by what I don't want. I don't want my T, so I'm going to divide both sides by T. T's cancel. R equals D over T. And it doesn't reduce. That's our answer. Okay, example 3. We're given 2m minus t equals sm plus 5, and we're asked to solve it for m. Here's where I really need you all to pay attention on this example, because our variable m, so I want to identify him, he's on both sides of the equal sign. So this brings back to what side do I want the variable I want on? I want him on the left. So my 2m's already on the left. My positive sm needs to come to the left, become a minus sm, equals, and then what's already on the right? My 5's already on the right, so I drop him down. What needs to come to the right? My minus t, I don't want him on the left, I want him on the right, so he becomes a plus t. And now we simplify if we can. So we're going to look at it and say, can I simplify 2 minus sm? No, because he's just a 2m and he has an extra variable s. So they're different terms. They're unlike. So can't simplify the left side. So let's look at the right. Can I say 5 plus t? Nope, because he's a number, he's a variable. Once again, we have unlike terms. So that's as far as I can go. So what do we need to do then to be able to get our m's by themselves? What we're going to have to do with this step, where we have 2 terms and each one has an m, that we're going to have to reverse the distributive property. So usually when I distribute, I multiply, so a common term. So what I'm going to have to do now is take out a common term. I basically ask, what are we solving for? Solving for m. So I'm going to take my m out. Then I'm going to make a parenthesis, because that's how distributive property looks like. And then my minus sign just drops down. And if I take out an m, that m disappears, I'm left with 2. Once again, if I take out an m, that m disappears, and I'm left with an s equals 5 plus t. Doesn't simplify, nothing happens to it. And then if you want to go back through and double check yourself, you say m times 2 is 2m, m times s is sm, so we're good. We did that part right. Now, we're still asking ourselves, what are we solving for? We're solving for m. So if m is right beside the parenthesis 2 minus s, that means they're being multiplied. So I need to divide both sides by what I don't want. And I don't want my parenthesis anymore. So 2 minus s, 2 minus s. So my parenthesis cancels out. I'm left with just my m now, equals. We look over here, 5 plus t doesn't reduce. Over s, 2 minus s doesn't reduce. And that's our answer, because nothing can reduce. Everybody just stays the way they are. Alright, example 4. If you would just read along with the word problem, we'll go along with each part as we go. So it says, use the information about the Kansas City hailstorm at the left. The formula for the circumference of a circle is c equals 2 pi r, and we're asked to solve, where c represents circumference and r represents radius, and we're asked to solve the formula for r. So once again, being a formula, I can flip the whole thing and take the left side, take the right side and write it on the left, take the left side and write it on the right. Now, step 1, identify our variable, r. So what's happening to r? He's right beside of a 2, who's right beside of a pi. So if they're all right beside of each other, that means they're all being multiplied. So the opposite of multiplying is divide. So we're going to divide both sides, but what I don't want my 2, I don't want my pi, all I want to keep is my r. Don't want my 2, don't want my pi. Okay. So then, on the left side, our 2's cancel, our pi's cancel. We're left with r equals c over 2 pi doesn't reduce. Okay, now part B. It says to find the radius of one of the large hailstones that fell on Kansas City in 1898. So that refers us over here to this reading. And it says on May 14th, 1898, a severe hailstorm hit Kansas City. The largest hailstones were 9.5 inches in circumference. Windows were broken in nearly every house in the area. So it says to find the radius. Whenever we go back and reread our question, it says find the radius of one of the large hailstones. So we're looking for r. When, and if you go back to the reading, it says 9.5 inches in circumference. And we know from up here, our circumference is our c. So 9.5 is our c. Now we're going to go back to our part A, right here in blue where we have our answer. R equals c over 2 pi. Okay, and now we know from our reading that we're solving for r, so r is already by himself. And we know that c is 9.5 inches all over 2. Now, what we can do is say that pi is 3.14, or if you can find the pi button on your calculator, you can also use it. So I'm going to do r equals, order of operations, so I have to multiply that bottom denominator first, so 9.5 over 2 times 3.14 gives us 6.28. And then 9.5 divided by 6.28 gives us 1.51, so I should round it to 1.5 inches in the radius. And we're good. We got our answer.